All right, welcome to section 7.1. Okay, the section we're still doing lots and lots and lots of factoring. Okay, there's a couple things we need to know. We are working with fractions, okay? And when any fraction, when does it not exist? So you're going to start off in section 7.1 talking about when is a fraction undefined. And the only time a fraction is undefined is if there's a zero in the denominator, okay? We don't care if there's a zero in the numerator, but if the denominator equals zero, it becomes undefined, all right? So all you worry about is taking the denominator. So in this instance, you're going to take x plus 7 and set it equal to 0. Subtract 7, subtract 7. And so x, basically what we're saying is x cannot equal negative 7. If x equals negative 7, then this expression would be undefined. Okay? What about this? When would this find any numbers for which the rational expression is undefined? So again, I'm going to take just the denominator, which is 7. When can 7 equal 0? And the answer is 7 can never equal 0. Okay, there is no x's, there's no variable. So this rational expression is always defined. And I can't remember how Math Excel put it, but there would be it's like the equivalent of no solution. Then you're going to go on to something called simplify this expression. Okay, so not only, and that means, guess what? We are back to factoring. So I'm going to look at that top, the numerator. And I'm in descending order, yes. Do I have a greatest common factor? Yes, I'm going to pull that out. That's 2. And then I have x squared minus 4, parentheses. On the bottom, I have a greatest common factor of 4. So that's going to leave me x minus 2. All right. Now I'm going to come and look at this guy. Can I factor him more? The answer is yes, because this is a perfect square. X times x gives me x squared. 2 times 2 gives me 4, and that is a minus. So that's the same as 2x minus 2, x plus 2, all over 4x minus 2. Okay, I have an x minus 2 and an x minus 2. With fractions, when we have similar numbers, we can cancel. When they have something in common, we can cancel. But note, when there's adding and subtracting on top, make sure it goes all the way around parentheses. You just can't cancel. So like if you went over here, you cannot just cancel the 8s, or you cannot cancel one of this x and this x altogether. You have to factor it out into the podding, because that plus and minus does something very special, so make sure you factor. The other thing we need to look at is the 2 and the 4. We can simplify that. So 2 goes into 2 one time, 2 goes into 4 2 times. So in the end, I would have the answer, what's left up on top. I have x plus 2. I can carry that one. That's not a big deal. I'm not sure if Math Excel will accept it or not, so you're better off leaving it without on Math Excel over 2. Okay? So all that factoring that we were working in Chapter 6, it is here to stay. We're going to keep working with it. All right, again, here, simplify this expression. Okay, you cannot go to 3 and 18, simplify it. Because of that plus and minus, make sure you do these little parentheses. Unless the little pods are exactly the same, you cannot do anything. So on that numerator, can I factor anything? Do I have a greatest common factor? Well, is it in descending order? Yes. Do I have a greatest common factor? No. So I'm just going to leave it as x plus 3. Now, what about this one? Well, the denominator, it's in descending order. It does not have a greatest common factor, so I'm just going to go pod. All right, well, x and x, how do I make a minus? A plus and a minus. And let's do 3 and 6. Let's test that. So that gives me positive 3. And the outsides give me negative 6. So that sums up to be negative 3. We're good. So we're good there. Okay, so now if I come back here, I note that my numerator and my denominator have something in common, the x plus 3, so that cancels and that cancels. But note that leaves me an x minus 6 down there in the denominator, but I need a 1 as a placeholder in the numerator. Okay, so it doesn't become x minus 6, it's 1 over x minus 6. Make sure you don't just put the x minus 6 in the numerator. All right, lucky us. This is a big one. We get to do double factoring. The numerator and the denominator both get factored. All right, so let's check. Let's make this x an x. I need a plus. Plus and plus 45. Oh, I bet that was supposed to be a minus 45. Let me change that to minus, and then I will make one of these minuses. Okay, what makes 45? Well, that's 1 and 45. And then it's 5 and 9, so I'm going to do my 5 and 9, so I'm going to put my 9 and 5. Test, the inside gives me 9x, the outside gives me minus 5x. Sum that up, and that gives me positive 4x. So I'm good there. And I'm going to just erase it so that we have it there. But always check this. So if you need to factor these on the side, do so. Okay. Again, let's try this factoring. I need a plus and a minus. What makes 72? 1 and 72. 2 and 36. 3 and 24. 4 and 18. 5 not. 6 and 12. 7 no. 8 and 9. So I'm going to put my 9 and my 8. Check the insides. That gives me a positive 9x. Check my outsides. Gives me a negative 8x. Sum that up, and that gives me a positive 1x, which is exactly what I want. All right. So now I've factored it completely. I can look. I've got a 9x plus 9 and an x plus 9, so I can cancel, leaving me x minus 5 and x minus 8. There's nothing left to cancel, so the answer is just x minus 5 over x minus 8. You may put parentheses around the x minus 5 and the x minus 8. The other thing I'm going to suggest you do with Math Excel is before you type in like x minus 5, just put in the fraction bar, push to the division sign so that you get everything in place. Because you're going to find out when you enter in x minus 5 and then hit the divide button, you're actually only dividing the 5 by and not the x minus 5. So just remember, it's all about factoring, okay? Email me or ask me in class if you have any questions.